Today, we're pulling back the curtain on a really fascinating piece of Windows engineering. How in the world it manages to run applications that were built for Linux.
Have you ever stopped to think about that? I mean, seriously, how can Windows possibly run a program that was built for a completely different operating system like Linux? They might as well be speaking different languages. They expect totally different things from the OS. On paper, it just shouldn't work. So today, we're going to peel back the layers on this little bit of technical magic.
Okay, let's dive right in. To really understand the brilliant new way this is done, we first have to take a trip back in time and look at the old way of doing things, the original Windows Environment Subsystem model.
So in the classic Windows architecture, you basically had two main areas. Up top, in what's called user mode, you had these things called environment subsystems. Now you should think of these as dedicated translators. An application would make a request, and its subsystem would take that request and translate it into a language that the core Windows kernel, running down below in kernel mode, could actually understand.
And here's the real kicker. Every single application, every single .exe file, was hardwired to one and only one of these subsystems. A normal Windows app? Yeah, it used the Windows subsystem. But Microsoft also built these translators for other environments, like POSIX or OS/2. The catch was an application was stuck with its translator for life.
Now, as you can probably guess, this whole translation model, it wasn't exactly perfect. In fact, it had some pretty serious drawbacks that kept it from ever being a really fast, high-performance solution for running programs that weren't built for Windows.
And hey, you don't have to take my word for it. The absolute Bible on this stuff, Windows Internals, puts it very plainly. The old model had important technical disadvantages. Basically, it was slow, it was inefficient, and it created this huge barrier to ever running non-Windows programs well.
Let's use an analogy here, because it makes it super clear. The old subsystem was like a full-blown embassy. Every single request involved this slow, formal, bureaucratic messaging process between the app and its translator. It was heavyweight with a ton of overhead. The new model, it's completely different. It's more like a special agent, lightweight, direct, and just incredibly efficient.
And that brings us to the really elegant solution that the engineers at Windows came up with, a brand new framework built around this idea called Pico providers. This is the special agent we were just talking about. So how does this actually work? Well, at the very heart of this new model are these things called Pico processes. These are not your normal Windows processes. They're a special, super minimalist type of process that doesn't need that heavy translator up in user mode. Instead, they're managed directly by a driver running deep inside the kernel, and that driver is called a Pico provider.
And this is the huge leap forward. That slow, heavyweight embassy is just gone. The Pico provider creates a direct, high-speed line between the foreign application and the Windows kernel, which gets rid of all that inefficient messaging back and forth.
Okay, so how does this really work under the hood? I mean, what gives these Pico providers all this power? Let's take a quick look at the anatomy of the whole system.
You know, the process is actually beautifully simple. First, the provider driver basically raises its hand and tells the kernel, hey, I'm here and I know how to manage a different kind of process. The kernel then hands it back a special toolkit, a set of really powerful function pointers. And with that toolkit, the provider can now create and control its own little universe of Pico processes.
And what's in this toolkit? Oh, we are talking some serious firepower. The provider isn't just asking the kernel for things, it gets the power to create its own processes and threads, to directly mess with the CPU context for those threads, and even access really low-level memory segments. This is deep, direct kernel-level control, something the old subsystem model could only dream of.
So we have this incredible, efficient new technology, but what is it actually used for? Well, this is where it all comes together in a really big way for anyone who develops software today. The Pico provider model is the secret sauce that powers the Windows subsystem for Linux, what we all call WSL. The entire Linux system call compatibility layer is, essentially, just one giant Pico provider. This is what lets it catch Linux system calls and translate them into Windows kernel calls at lightning speed, letting you run native, unmodified Linux programs right there on Windows.
And for developers, this is an absolute game changer. You can run your entire Linux toolchain, your scripts, your command line tools, right on your Windows machine, without having to fire up a slow, memory-hungry virtual machine. The integration is seamless, and the performance is fantastic, precisely because this Pico model has almost no overhead.
So let's just zoom out for a moment and recap why this engineering shift from the old subsystem model to this new Pico provider model is so incredibly important.
Let's break down the big advantages here. First, the Pico provider model is just way more efficient. It completely gets rid of that old, slow client-server overhead. Second, it's incredibly flexible. This architecture isn't just for Linux, it could be used for other operating systems too. And finally, the impact is just undeniable. It's the tech that enabled tools like WSL, which have completely transformed what it's like to be a developer on Windows.
And that leaves us with a final, really fascinating question to think about. Since this model is so powerful and so extensive, what could be next? What other
Please smash that like button, leave a random comment, and subscribe if you want to become a better hacker.